Unit 10 is what we call matrices. So those A and B are two examples of what are matrices. Matrix or matrices are just, it's a fancy way to kind of organize data. Okay, organize numbers. Realistically, if I put lines in here, if I put a line right here and I put a line right here and I put a line right here, and instead of putting brackets, we just have these line things, what does it look like? A table, an Excel spreadsheet, right? Okay, it's essentially an Excel spreadsheet. Matrices are a way to organize data using essentially an Excel spreadsheet before Excel spreadsheets existed. Okay, that's what it is. I mean, we can look at this as, okay, this is the number of small shirts I have. This is the number of medium shirts that I have. Okay, so I have this many smalls, I have this many mediums. So these are called columns. Okay, so this is for your notes. These are called columns. Okay, so where I have the S and the M, those are called columns of a matrices. Okay, matrices are made up of really two things. They're made up of columns. They're made up of several things, but they're made up of columns and they're made up of rows. Columns and rows. How do you keep them straight with which one's a column and which one's a row? The only way I can keep it straight in my limited mind, okay, is by thinking like the columns of a coliseum. If you've seen the coliseums, they've got those round columns that go down. They go up and down. So columns in my brain, I don't even know if that's what they're called. What do you say? That's what my brain says they are. It says they're columns of the coliseum. So columns go up and down. Rows go across. Okay, so we could say that this is a Viking shirt. This is a Green Bay shirt. And this is a San Francisco shirt. Okay, so my columns are small and medium. My rows are teams. So what I could do then is I could say, if you think about what this says, if I want to interpret what that 3 means with my columns and with my rows, it means that I have 3 small Viking shirts. Okay, column-wise, I come down to the 3. Over-wise, I go over to the V. So I have 3 small Viking shirts. Okay, columns are up and down. Rows are across. Columns up and down. Rows across. So if I highlight this one right here, and I ask you to interpret that, it means that I have -5 medium Green Bay shirts. Okay, probably a bad example with the negative, but whatever. Okay, this one in pink means that I have no small San Francisco shirts left. Going by the row and going by the column. Okay, so we've got rows, we've got columns. From a technical standpoint, each of these pieces is called an element. It's called an element, and you could even say it exists in a specific location. We're not going to get that much involved into it, but just keep in mind exactly what these things mean. Okay, you're not going to have labels on them. You're not going to do those types of things. Okay, but we have columns and we have rows. So how many columns does this have? 2. This has 2 columns. How many rows does it have? 3. Okay, so it has 2 columns and it has 3 rows. So the first thing we want to be able to do, if we look at this one, it's kind of the opposite, right? It's got 2 rows and 3 columns. Okay, so one of the first things we want to be able to do with matrices is we want to be able to describe them by the dimensions. So when we describe a matrix by its dimensions, we're always going to go, and I probably did it the wrong way when I just did that last one. I should have switched it around, but whatever. When you're talking about the dimensions of a matrices, it's the number of rows by the number of columns. So when we name it, you name it by the number of rows that it has, by the number of columns it has. So its rows are by, we're going to make that a multiplication symbol, columns. It's the number of rows by the number of columns. So if we look at these two matrices, and I'll give you a couple seconds to write them down. And we want to put dimensions to these. Again, there are no lines. These are just separations. It's -2, -1, -1, that's my first row. -1, 5, 1, that's my second row. -2, -1 is my first column. -1, 5 is my second column. And my third column is -1, 1. Okay. So, when we name this, we name it by its rows and by the number of rows by the number of columns. So in this first one, how many rows does it have? 2. So we say it has 2 rows by how many columns? 3. So we call that matrices a 2 by 3 matrix. That's the dimensions of it. It's 2 by 3. So anytime you're asked what are the dimensions of the matrices, it's the number of rows by the number of columns. Rows by columns. Rows by columns. Columns go this way. Rows go this way. Rows by columns. If we look at the second one, how many rows does it have? 3. How many columns does it have? 2. So we have a 2 by 3 and a 3 by 2 matrices. Again, the number of rows by the number of columns. Now, knowing their dimensions is important because when we add or subtract or multiply, certain things have to happen with their dimensions. Okay? So this is just looking at them and stating what the dimensions are. Easy enough? Rows by columns. The next thing we want to be able to do with them then is we want to be able to take these, well, let's just do these two, I guess. Let's go ahead and just state them real quick. I got to slide ahead, I guess. So the first one, 6, -1, and 2. How many rows does it have? 1 row. How many columns does it have? 3. So that's a 1 by 3 matrix. The second one here, how many rows does it have? 4. How many columns does it have? Just 1. It has 4 things going this way. It has 1 thing going this way. That's why it's a 4 by 1. Do those 2 things make sense? Yes? Okay, so where I was going before I forgot this slide was inserted, why does it make a difference with the dimensions? Well, when we're adding and subtracting, and our whole thing today is going to be adding and subtracting and scalar multiplication. When you add or subtract matrices, they have to be the same dimensions. When you add or subtract matrices, they need to have the same dimensions. So you can only add a 2 by 3 with a 2 by 3. You can only add a 1 by 4 with a 1 by 4. If you have a 2 by 3 matrices and a 3 by 2 matrices, they don't have the same dimensions. So you can't add them or subtract them. Doesn't mean you can't multiply them, but you can't add them or subtract them. They have to be exactly the same matrix in order to add or subtract them. So the first thing you should always do, if we're going to take these 2 matrices and add them, and I'll give you a couple seconds to copy down that matrix. But as you're copying it down, the first thing you have to keep in mind is the dimensions. And you want to check the dimensions. So if we take the dimensions of the first one, It has 3 rows. It has 2 columns. So it's a 3 by 2. The only way I can add the second one to it and third one and fourth one, because you can add multiples, is if it's a 3 by 2. Is it a 3 by 2? Yeah. So I can add these two together. So that's the first thing you check, is you check to make sure that you have a 3 by 2. And the rows and the columns match up. The dimensions are the same. So we have a 3 by 2 and a 3 by 2. When you add them together or subtract them together, your resulting matrix is going to have the same dimensions as well. So we are going to have another 3 by 2 matrix. Well, how do we get the elements? You add the ones that are in the same location. Okay. So to figure out what goes here, what that element is going to be, all I have to do is add those two numbers together. So negative 2 plus 2 is 0. So that element right there is going to be 0. To get this element here, I'm going to add the elements that are in the same spot. Negative 4 plus negative 6, negative 10. This is negative 10. To get this one, it's that added together. What do I get when you add those together? 1. All right. Next one. Because we're having so much fun with the colors, I made this way too big because I was going to do it a different way, but the colors work, right? What's 3 plus 4? 7. Go ahead and see if you can figure out the other two elements. See if you can figure out the yellow one. And see if you can figure out the red one. So the yellow one's going to be negative 2 plus 3, which is 1. And the red one, negative 6 plus 3. Can't see that because it's too dark, but it says negative 3. It's not so bad, right? Oh, it's not so bad. Any questions with that one? I was going to put up here negative 2 plus 2. I was going to write all that in, but then that started like too much writing, and I could just color code it. Color coding is kind of cool. Of course, you don't have highlighters, so you can't do that. But, oh well. Just have to read my notes forever.
Yeah, I was going to do that too. That makes it easier for me.
All right, so let's look at this one. So we've got negative 5, 0, negative 3, negative 1, negative 3, negative 5. We're going to go plus negative 6, 6, 4, and negative 5. So what are the dimensions of the first one? How many rows does it have? 3. How many columns does it have? 2. So it's a 3 by 2. How many rows does the second one have? 2 by 2. So we've got a 3 by 2 and a 2 by 2. Can you add them together? Nope, can't add them together. Because these two things are different, that's your red flag right there. Nice. That's your red flag. Can't be done. You're done. Can't be done. So if you get one like that, just said can't do. Simply put can't do. So we've added. Let's subtract one. All right, so we'll call this number 5 down here. Let's go negative 3, 6, 0 and 1. And now we're going to subtract 4, 2, negative 3, and 8. Okay, so now we're going to subtract. So first, can we do it? Yes. We can do it. We've got a 2 by 2 minus a 2 by 2. So we're good. So we know our end result over here is going to be a 2 by 2. My 2's changed from one to another. Okay, so we got a bunch of 2 by 2's. That's okay. So now what you got to keep in your mind straight. So now we're subtracting. So now the color codeness in this one, that subtracting always gives us issues. Always gives us issues. So me color coding this one probably isn't the best way to do it. I might write this one down because I've got negative 3 minus 4. That's what's going to go in that spot. Negative 3 minus 4. Does everybody see why that's that? I've got negative 3 minus 4. Now, negative 3 minus 4 is negative 7. For the element right here, which would be the first row, second column, that's going to be 6 minus 2. 6 minus 2 is 4. For the second row, first column, it's 0 minus negative 3. What's 0 minus negative 3? A minus and a minus makes a plus, so that's positive 3. And the last one is 1 minus 8, which is negative 7. You just always have to be careful with subtraction. I know you guys can subtract. I know you can add. I know you can subtract. But so many errors happen because you just start looking, you skip it. If you can, in your mind, which I'm sure 99% of you can do, probably 100% of you can do, if you can remember it's just negative 3 minus 4 and put minus 7, you don't need to write this down. Or punch it in your calculator, negative 3 minus 4. Just don't forget the subtraction sign. You never forget the addition sign. That's why I did the color coding up there. It's just adding. Be careful when you do the subtraction. Don't forget the subtraction. It's like when we do the distributive property with that dang minus. We always forget to distribute it. That still needs to be distributed. Okay? We good with adding and subtracting? Right. Second part of today then is what we call scalar multiplication, and this is even easier. Scalar multiplication means that you're going to take a singular thing. Scalar means singular. Negative 2. And you're going to multiply it by this matrix. Okay, so you've got this matrix here that, remember, this is rows and columns. This is shirts, and this is teams. If we're going to multiply it by 2, so if I have, I think this was the Vikings and Smalls, I have 4 small Viking shirts. I'm going to multiply this by a scalar multiple of negative 2. What do you suppose I'm going to do with that negative 2 and the 4? I'm just going to multiply them. If it was 2, I would have 8. If I was going to multiply my numbers by 2, I'd have 8, right? It doesn't change if it's negative. We just multiply. So when you do scalar multiplication, all you have to make sure that you do is that you multiply that scalar by everything. So my new matrix, it's going to be the same dimensions. This is 3 by 2. My new dimension is going to be 3 by 2. Negative 2 times 4 is negative 8. Negative 2 times negative 3 is 6. And I am terrible at drawing these things. Negative 2 times negative 3 is 6. Negative 2 times 0 is still 0. Negative 2 times negative 2 is 4. And negative 2 times 3 is still negative 6. So that's my matrix multiplied by a negative 2 as my scalar. So when you're doing scalar multiplication, all you're doing is distributing that scalar into each of your elements. And again, think about it as t-shirt sizes and teams. If we're going to do it by 2, now we have 8 t-shirts instead of 4. Okay. And again, scalar multiplication doesn't matter where it happens. It doesn't matter what the dimensions look like. The dimension of the matrix that you started with is the dimensions of the matrix that you finish with. Go ahead and do the scalar multiplication for that one. Hopefully you won't have to break out calculators, but you might. Can I touch them? So they go like, to me, they're like inside out. Should we turn around? So like this part should be in your ear.
No, it should that hurt.
Why?
Because it's going to walk your ears worse. Why would that part be in there?
So it's like the empty part of a headphone.
No, what?
I'm right, you're wrong.
No.
Okay? So 15, 12, negative 12, 3, 3, 3. Any questions with that one? So you can name them by dimensions, columns, rows. But when you name them, it's rows by columns. Add them. They have to be exactly the same dimensions. Add the elements. Subtract the elements. Be careful when you subtract. And then multiply scalar multiplication. Okay?